I'm Juliana Bauer,
Hey everyone, I'm Alex Lopes.
and this is our presentation on our Mount Hope Bay water quality plan. For those of you who don't know, Mount Hope Bay is located between Rhode Island and Massachusetts and is home to many diverse wildlife communities. Mount Hope Bay, though it is beautiful, faces very multiple environmental challenges, so that we will dive deeper throughout this presentation. Though in a watershed plan, there are many resources that are involved, and the most important resource is stakeholders. The stakeholders involved in this project are federal, state, and local government agencies that all have offices within this watershed area, recreational users, conservationists and researchers, indigenous tribes, farmers, commercial fisheries, commercial and residential developers, and finally, local businesses from both Rhode Island and Massachusetts.
All right, so what are our concerns here with our watershed? Let's say the most pressing threat to the Mount Hope Bay watershed is the water pollution due to nutrient loading from agricultural fertilizers, septic systems, and wastewater treatment plants, specifically excess nitrogen and phosphorus entering the bay. The additional nutrients trigger algal blooms, depleting oxygen in the water, and impacting species across the marine ecosystem. Stormwater runoff from urban and suburban areas across our watershed carry contaminants, bacteria, oils, and other pollutants into the streams and rivers, especially after heavy storms. Over time, these significantly degrade water quality and aquatic habitats. With the expansion of urban and suburban centers across the bay, green, riparian zones and wetlands have been destroyed or lost to make way, further minimizing the natural filtration system that once existed to siphon out those harmful pollutants. As the character of the bay changes, so does the threat of invasive species and their impact on native plant, bird, and fish species that allow this food web to thrive. Additionally, the challenge of climate change, rising sea levels, the frequency and strength of storms, increasing temperatures, all force additional pressure through flash flooding, the overwhelming of waste and stormwater infrastructure, farm runoff, etc. We generally care because clean water directly affects the quality of life for all stakeholders and community members across the watershed. This ties directly into strong biodiversity that was fish, the shellfish, birds, and plants, the local economy, tourism, and recreation. So our two main objectives to get after improving the water quality of the watershed are first and foremost, decreasing the pollutant levels, and second, increasing shellfish abundance in Mount Hope Bay. For the first one, this centers on a cooperative approach that reduces the amount of nitrogen and phosphorus entering our streams and rivers. The second one, to increase shellfish abundance as a means to filter out pollutants. The goal here is to identify the best method and location to focus shellfish habitat restoration and protection as a natural filter that improve water quality. With the threats currently facing our watershed, these objectives support water quality improvement from complementary angles with the same end state in mind, which is a safer, healthier Mount Hope Bay.
So to help us reach our goals for our management objectives, we propose the following management recommendations using funding from government and local organizations that we have listed here. So to start off, we have planting different shellfish species. Planting these native species in different life cycles around Mount Hope Bay, in both areas with and without shellfish fishing restrictions, has the potential to significantly increase shellfish populations. Restoring shellfish populations after fish kills from harmful algal blooms can increase ecosystem productivity and fishing yields.
For biological remediation, this recommendation focuses on reintroducing and expanding shellfish populations to naturally absorb those pollutants we talked about from the water. While this approach is cost effective compared to some of the other methods that we have, it comes with slower returns, making long-term commitment and public support that much more essential. Protecting restored shellfish beds, possibly through restrictions on fishing and recreation, will be absolutely vital to ensure the strategy's success over the long term.
We are also planning on developing new fertilizers. New fertilizers are experiments are being completed by scientists and can potentially reduce nutrient runoff, thus decreasing the pollutant levels and nutrient levels found in different water bodies. This is done by new fertilizers that slow the release of nutrients into the soil based on the nutrient needs of the crops, maximizing absorption in the soil. By maximizing absorption in the soil, there is less of a likelihood of having these water bodies be polluted from different agricultural areas. And to build off that, we're also planning on developing new farmer training programs and partnerships that can inform the farming community about the dangers of nutrient runoff and develop better timing techniques for applying fertilizer. Laying fertilizer during peak growing seasons or during specific plant life stages has been seen to limit nutrient runoff because the crops are absorbing the maximum amount of nutrients. We are also planning to monitor these nutrient and pollutant levels by placing monitoring buoys where rivers flow out into Mount Hope Bay. These monitoring buoys can report back to scientists about the different chemical and physical attributes of the ocean, but the most important attribute we are monitoring are chlorophyll levels. If there are high chlorophyll levels, this may mean that there is a harmful algal bloom or there is about to be. We are also planning on removing man-made structures in the area. Man-made structures such as dams, bridges, and roads can restrict tidal flows in salt marshes, destroying ecosystems and trapping pollutants. Removing man-made structures that are abandoned or provide no significant value to stakeholders present could assist in restoring tidal flow and restoring wetland environments to a more natural state.
Additionally, for wastewater treatment upgrades, this alternative will aim to reduce nutrient pollution at the source. We will assess how various retrofit technologies that we would install affect nitrogen phosphorus concentrations both at discharge points and further downstream across sediment and water. To guide decision making, it will also account for each upgrade's effectiveness over its life cycle, balancing initial investments with long-term pollutant reduction benefits. And lastly, green filtration. This alternative seeks to harness the power of natural landscapes by expanding and optimizing green space to absorb that runoff and filter pollutants. This model will examine how increasing green space correlates directly with reductions in nutrient loads across the watershed. However, this strategy may face resistance, as we would expect from developers and competing land use interests. Ongoing monitoring and clear communication of those benefits, backed by strong regulations, which are absolutely essential, will be key to protecting and expanding these areas.
So, in order to implement all these management recommendations, this plan will go over a 5-year time span where each year we are monitoring and implementing our management recommendations. And in order to monitor these recommendations, we are developing models to prove that these models are successful. So, for planting shellfish species, the planting of shellfish species after they are planted using hydrodynamic models and quantifications of shellfish larvae and spatial recruitment patterns. If these models show that there is a significant increase in shellfish densities in the majority of the harvesting areas, we will know that our efforts have been successful.
For bioremediation, monitoring here will take place monthly through habitat surveys and water sampling, particularly in areas where shellfish are expected to thrive. Scientists will track not only the water quality, looking at pollutant levels and dissolved oxygen, but also whether the introduced shellfish are successfully settling and reproducing. Using models and larval tracking, they'll observe where shellfish populations are growing or declining, helping identify trends across seasons and years, and understand how shellfish health connects to overall, water quality.
For the monitoring buoys, collecting water samples near these different locations and testing them in a lab for different nutrient levels and algal concentrations will allow us to determine if there has been a significant decrease in pollutants in the water column. And then for after completion of farmer training programs and new fertilizer development, we will test for phosphorus and nitrogen levels. By measuring for nitrogen and phosphorus levels, we will be able to see if the new fertilizer and training programs are effective, if there is a significant decrease in these pollutant levels. For the removal of man-made structures, during site visits to different man-made structure sites after the removal with scientists and local volunteers, these individuals will collect data and environmental conditions assessments to determine if the tidal restrictions in the area have been significantly improved. If scientists determine that these collections are positive for the environment, we will know that we have reached our desired changes in our watershed area.
Those wastewater treatment upgrades, these will enhance with real-time monitoring technology, where inline sensors are installed at the discharge points and will continuously track nitrogen phosphorus levels in the discharge. While data will be reviewed monthly, any spikes in pollution will trigger an immediate response from treatment staff. Over time, this data will also be used to evaluate the performance of a range of different technologies that we've installed across the watershed we'd like to use for future investments so we can prioritize the most cost-effective system. And lastly, for green filtration, for this one, sensors and soil tests done quarterly and after major storm events. These will help determine how well these spaces are working. This ongoing monitoring will pinpoint areas where runoff is still a problem and inform where to expand green infrastructure for the greatest impact on water quality.
And that is our presentation on our Mount Hope watershed plan. I hope you enjoyed.
Thanks, everyone.